Okay. So do you guys have this one done? This one should be done from my video from yesterday. Okay. So we're gonna do number 6 and 7 today. So get ready, it's gonna be super exciting because it's number 6 and 7. Okay. The only difference between this one and this one is that I have two of the same thing. So I'm gonna make my 2 by 2 box again. And put -6 minus 4i on the top and the side. Okay, -6 times -6 is positive 36. -6 times -4i is positive 24i. -4i times -6 is a positive 24i again. And -4i times -4i is positive 16i squared. I guess all the negatives make them all positive, which is great. Okay. Combine like terms. 36 plus 48i plus 16i squared. Okay. So the next step is make I squared -1. And I'm hoping that you heard me on my video yesterday say that this problem would be done here if this was any other letter than I. But because it's I, it has a special property where I squared is -1. Which makes that -16. And then I combine those two and get 20 plus 48. You guys have any questions about number 6 before we move to number 7? We'll make sure we're done with 6 before we go to 7. We're done. Okay. Number 7 is a log problem. And I don't know, I'm a weirdo again. I have really like weird ways to describe this stuff, but I call this a squirrel in the tree problem. I know. I have like all these little silly things. This one I stole from Mr. Guinan. So Mr. Guinan says that if you have a squirrel stuck in the tree, which means that your exponent is your variable, so the answer is stuck on the exponent, what do? You hit it with a log on both sides and knock the squirrel out of the tree. That I didn't make it up. I swear it's Mr. Guinan. You can picture him saying it, right? Yeah. Anyway, okay. Now, before I log both sides on this problem, I need to get the base, exponent, and answer alone. So I need to divide by 9 first. And I'm pretty sure 44 over 9 is awful. So I'm just going to leave it like that for the minute. You can find the decimal if you like. I'm just pretty sure that it's not a good one because I'm assuming 4 9 makes something repeatingly bad. Okay, now this is the point where I have base, exponent, and answer. So to get the exponent to where I can solve for it, I'm going to log both sides. You can do parentheses. Okay, and then I'm going to use the power property of logarithms, which says the exponent goes in front and becomes multiplication. This is where I really suggest that you use parentheses to kind of protect that r plus 2 as its own number. Okay, now we want to get r by itself. I'm going to divide both sides by log 3. And this is where I'm going to go to the calculator for the first time myself. You might have gone to the calculator before now, and that's okay. So log 44 ninths divided by log 3. And if you notice, it says round your answers to the nearest 10,000th, which is 4 decimal places. So I'm going to say 1.4445. And then subtract 2 from both sides. And I got negative 0.555, and then I'm going to round that to a 5. So negative 0.5555. Okay, can you guys please look at the worksheet from yesterday? The solving, no, what was it called? Graphing polynomials worksheet? You guys have any questions on it that my video did not answer and or the answer sheet did not answer? Anything you want to ask me about this worksheet? Are you sure? Are you sure you're sure? Are you sure you're sure you're sure? Yes. 14, sure. Ah, yes. Okay. So number 14 requires 2 steps. I don't think you can complete the problem though from, did anybody do it in 1 step or do you have to do it in 2 steps? I think you have to do it in 2 steps, right? Okay. Anyway, so I noticed that the setup is side angle side. And side angle side means I have to use law of cosines. And I understand why you would not want to do that because that's not going to give you angle Q. But what you have to do is get the side across first and then use that to do law of sines to get angle Q. So let's just do it while we're here. So x squared equals 28 squared plus 30 squared minus 2 times 28 times 30 cosine 105. Okay, now at this moment, I want you guys to tell me, would you prefer to do law of sines to find the angle Q, or do you prefer to do law of cosines again where you have side, side, side? I like law of sines better personally, but you have options. So I would draw my arrow to the 30 and say sine of 105 over the side across equals sine of Q over the side across. Cross multiply. And then the most important thing that I want to make sure we're all getting is that you need to do the inverse when when you're solving for an angle. We need to make sure to do that inverse at the end to undo sine. Do you guys know what the answer is? Is it 39 degrees? Okay. That was definitely a spicy problem because you couldn't do it in one. You had to do two completely different things. In third period, they told me they liked the side, side, side law of cosines better. And I was like, really? Okay, go for it. I don't know. But anyway, um, okay, so just scooch that paper aside, please, and grab your notebook. Um, so I really, really like this lesson. So, and it's hopefully short-ish, which is good, because I don't know if you noticed, but I haven't stand dancing, which irritates my Virgoness very greatly. But it's okay because Miss Rice told me that she was an infrequent stamper. So that you guys are probably used to infrequent stamping. I don't like to do infrequent stamping, but it's okay. But so I'm gonna try to finish this and do as much stamping as possible. If I don't get to you, please do not freak out. I'll just do my best. Okay, number 40. That's not gonna be helpful. 1, 6. Okay, number 40. This is, by the way, a really dumb question, but I'm hoping that it will kind of set your mind as to what we're going to do today. Number 40, what is the difference between the graphs of the function y equals x squared, x minus 3, x plus 1, and y equals 3x squared, x minus 3, x plus 1? What's the diff? That's really kind of silly. Yes. The a value of 3. Do you guys remember what the a value does to a graph? Yeah, it's a vertical stretch by a factor of 3. So it just means that it would be skinnier. We don't really know what it would do to a polynomial at this point, but the clue is we're going to start working with a, which we haven't really done yet in this chapter. So for number 40, we're going to write okay, number 41. Are the intercepts enough? Melvin wrote the equation y equals x plus 3, x plus 1, x minus 2 squared to represent the graph at right. Okay, so let's talk about what Melvin put real quick before we move on. Let's see where he got these things from. Melvin is saying that there is a single root, which means the graph passes through -3. Does this graph pass through -3? Yes. Does it pass through -1? Yes. Does it bounce at +2? Yes. Okay. So that's what Melvin is saying. He's saying, I see a pass through at -3, I see a pass through at -1, and I see a bounce at +2. Explain how you can decide whether this equation represents the graph. What can you do to the equation to make it a better fit for the graph? What equation would fit better? Okay, we're just going to skip all of that and go straight to what they're actually getting at. Can you guys write this, except for that I'm going to make it so that you can actually see it. Can you guys write this right next to where it says 8-41 on your paper? Okay, and then next to that, write this coordinate. Okay. First thing I want to tell you is that P of X just means polynomial of X, like f of X. It's not special, it's just Y. So over here, label your coordinate X and Y. And we are going to plug in for these to solve for A. So 16 equals A, 1 plus 3, 1 plus 1, 1 minus 2 squared. 16 equals A times 4 times 2 times 1. Everybody see where I got the 4, 2, and 1? You sure? Okay. 16 equals 8A. Divide by 8. 2 equals A. P of X equals 2 x plus 3, x plus 1, x minus 2 squared. Do you guys remember doing this in chapter 2? And the test from chapter 3. Those problems were a little different. They gave you a graph usually, and it said like, find the locator point, and then find another point, and plug those in for HK, X, Y, and solve for A. And you looked at your blue sheets, if you remember, to figure out like what type it was, and then you wrote down the general equation. Our equations are going to come from the x-intercepts or the roots on the graph. So we're going to put the roots or x-intercepts down in the factors in the parentheses, and then we're going to plug in a point to solve for A. The last thing I want to say is this the final answer? I mean, it is to this problem, but you need to make sure you read the directions. This is factor 4. And you get really excited when it says leave your answer in factor form. You have a little party in your mind. Because what would you have to do if it said standard form? Multiply out all the boxes. Let's just talk, we're not doing it, but let's just talk about what that would look like. Well, for me, I would start with the squared term because I wouldn't want to mess it up. So I'd make a box that was x minus 2, x minus 2, and get stuff. And then I would do a 2 by 3 box with that, and I'd get more stuff. And then I'd do a 2 by whatever box with that, and get more stuff. And then I would distribute the 2 at the end. That would be 3 boxes and distribute. Boy. Yay. Okay, could you do it? Sure, you could. But do we want to? Absolutely not. Especially on a Friday. Negatory. Okay. We're gonna get back on and go again. 8:42. Okay. I'm gonna zoom in a lotsies here on purpose. Hopefully find that this is what I want. Okay. All right. The first thing we're going to do is write our equation based off of the roots. Okay, you guys all write y equals. So next to 842, write y equals A. Okay. Now we're going to go from left to right and right to 0. What is this? X. And you can put x minus 0 in parentheses if you want. But I just put x. You guys all understand what I'm saying? So it's 0. It's passing through at 0. So you say x in the front, or you say x minus 0 in parentheses, whatever your brain likes better. Okay, moving on. Oh. X minus 2 quantity squared, right? Because it's a bound. At 2, we make it x minus 2 quantity squared. By the way, the music that I am stolen from The Price is Right. X minus 3, and it's just a single root, right? Because it's passing through. Okay, so let's just say this again. You have, hopefully on your paper right now, y equals A. X. Parentheses. X minus 2 quantity squared. Parentheses. X minus 3. Do you see where those things came from? Okay. The hard one about that one, I think, is the X. Okay, hold on. You guys are ahead of me. Now I have to catch up. Okay, now what else do I need to solve for A? Yeah, some kind of XY coordinate. Let's see if we can search the problem without reading it to find the coordinate. Oh, there it is. Okay, so 2.5 decimals, Mrs. Talbot? Negative 0.2. Okay. It's all right. We have calculator today. So x negative 0.2 equals a 2.5, 2.5 minus 2 squared, 2.5 minus 3. Okay. Use my brain here, see how far I can get. Negative 0.2 equals 2.5. Okay. 2.5 minus 2 is 0.5. 0.5 squared is 0.25. 2.5 minus 3 is negative 0.5. Oh man, I think I have to go to the calculator now. What is it? Let me pause here. Do you guys see where the numbers are coming from? So this is this minus this squared is this minus this is this, and then I multiplied all three of those together and put it in the front. Is that clear? Okay, now I'm going to divide both sides to get a by itself. No, no. Mm-mm. Final answer. In factored form. Are you guys getting the hang of it? Is anyone getting the hang of it? Okay. Okay, this guy right here is 43A. We're gonna do the same thing. On your paper, write y equals A. Right next to number 8-43. 8-43, y equals A. Okay. Right here, what is that? -2? That's about a -2, correct? Okay, so you're gonna write x plus 2 quantity squared. Does that make sense? Okay, and then what's this? X minus 2 regular. Okay, so you have y equals A. X plus 2 quantity squared, x minus 2 regular. Okay, now they're indicating on this problem a point that you should plug in. Do you see the point that they are indicating? Right there, 0, 16. Okay. I'm going to freeze the screen. Work in your groups, please, to figure out A and write the factored form equation just like we did before. Speaking to each other's fine. When you're ready, look up at the screen for your spoiler. Okay. Pausing here. You guys clearly have a quiz only from today. You can see it on your sheets. Right, we have a, it's on there, no problem. The bold. We have a quiz week from today. It has two questions. The first question is like that one, number 31, where it gave you an equation and you had to sketch it. So you state the degree, you state the roots, you put the dots on the x-axis and you sketch it in. You know what I'm talking about? Okay. And the second problem is just like this. You have a graph. You write the equation based off the roots. Get a point. There's going to be a big like dot. Plug that in for x and y, solve for a. On this quiz, it's going to say factored form, which is great news for you. On the second quiz, it's going to say standard form, which is not great news for you. Okay, so number 44, this is your challenge. I'm going to put up the graph. I want you to, in your groups, write down the equation with a based on the roots, plug in a coordinate, solve for a, multiply it out into standard form. I'm only gonna ask you to do that one time today, but we need to practice it because last year I didn't practice it enough and almost everyone, including my smartest students, forgot to distribute the a value at the end and got a point off. So I can't have that. Okay, so I'm gonna put up the graph for 44. Write down the equation based off the roots with a, get a point, plug it in, solve for a, multiply it out to get standard form. I'm going to do the same over here. By the way, I'm going to put my cursor on which point I'm going to use. You can decide. Definitely talk. I almost made a mistake. I almost called that 0, -4. That was close. Okay, wait, does it come out with a fraction A? Okay, forget it, 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 forget it. No, do the problem, just don't do the standard form part. Because it's a fraction, I'm not gonna make you do that. It's just do the same thing we did for 43. Yeah, did you get it? Do you got negative 3/4? Is it because the 0 minus 1 squared is positive 1 and then, okay, okay, just checking. Is it negative? It should be negative though, because it's facing downward. Okay, ready? When you're ready, take a look. Okay, we're gonna do the standard form on the last one instead. That one has a whole number. I can't do it with a fraction. It's just, I can't do it to you. Okay, but are you guys okay with the rest of that process up to here? Okay, so we're gonna do this again. Last time. This time we're going to do standard form. Except for I think it's actually 44 in the book. Okay. So pretend this is 45. Just ignore the 44. I don't want to do 45, it's dumb. Okay. So you're doing this one next to the 8-45 spot. I know, it's weird. I do my own thing a lot of times because CPM, they ask you all kinds of crazy questions. Okay. Write a polynomial equation for a function with a graph that bounces off the x-axis at -1, 0, crosses it at 4, 0, and goes to the point -2, -18. Okay, so this one, you're gonna write the equation, solve for A, and get it to standard form. Okay, so there's your first hint. That's the part you should have written down from the problem itself. Minus 12? Yeah. Okay. Okay, so when do you have to do that, all of that multiplying? What does the problem have to say? Standard. If it says standard, you have to do all that. That's when you're like, oh no. But if it says factored form, you just get to leave it. The biggest question is though, do you know how to solve for A? Do you know how to write down the equation based off of the roots and what they're doing and solve for A? Because that's what this lesson is supposed to be about.